Imagine waking up tomorrow morning and discovering that every gas station in America is empty. No fuel, no deliveries, no gasoline. Within hours, millions of cars would stop moving, trucks would stop delivering food, airports would face disruptions, and entire parts of the economy would begin slowing down. That's how important gasoline is. But here's something most people never think about. The gasoline flowing into your car today started its journey as a thick black liquid buried thousands of feet beneath the Earth's surface. A liquid so dirty, heavy, and contaminated that if you poured it directly into a modern engine, the vehicle probably wouldn't make it very far. So, how does that black sludge become the crystal clear fuel that powers millions of vehicles every single day? The answer involves one of the most impressive manufacturing systems ever built by humans. Today, we're going inside a modern oil refinery to follow the complete journey of gasoline, from crude oil deep underground to the fuel that ends up in your gas tank. The story begins millions of years ago. Long before humans existed, enormous quantities of marine plants and microscopic organisms settled on the floors of ancient oceans. Over millions of years, heat and pressure transformed this organic material into crude oil. Today, oil companies drill deep beneath the Earth's surface to reach these underground reserves. Some wells extend thousands of feet below ground. Powerful drilling rigs work around the clock, extracting crude oil and pumping it to the surface. But here's where things get interesting. The liquid coming out of the ground isn't gasoline. It's not diesel. It's not jet fuel. It's a chaotic mixture of hundreds of different hydrocarbon molecules combined together. Some are light, some are heavy, some are useful, others are not. The refinery's job is to separate and transform this mixture into products people actually need. Once the crude oil is extracted, it begins an enormous journey through pipelines, tanker ships, rail cars, and trucks until it finally reaches one of the giant refineries scattered across the United States. And these facilities are enormous. From above, many refineries look like entire cities built out of steel. Miles of pipelines, massive storage tanks, towering processing units, flames burning from stacks, thousands of valves, thousands of pumps, and everything operating 24 hours a day. As soon as the crude oil arrives, it enters giant storage tanks. Some of these tanks are so large they can hold millions of gallons. Before processing begins, laboratory technicians collect samples. Because every batch of crude oil is different, some contain more sulfur, some contain more gasoline-producing hydrocarbons, others contain heavier compounds. Understanding the chemistry helps engineers decide how the oil should be refined. Once testing is complete, the crude oil enters the desalting unit. Now, this might sound boring, but it's actually one of the most important stages. Crude oil contains dirt, salt, sand, and other contaminants. If these materials remain in the oil, they can destroy refinery equipment worth millions of dollars. Inside the desalting unit, water and electrical systems separate these impurities from the oil. The contaminants are removed. The cleaner oil continues forward. Now comes the first major transformation. The crude oil enters giant furnaces, and the temperatures here are extreme. The oil is heated to nearly 400 degrees Celsius. That's hot enough to instantly vaporize many of its components. As the temperature rises, the thick black liquid begins transforming into a mixture of hot liquid and vapor. And this is where the real magic begins. The heated mixture enters a gigantic distillation tower. This tower is the heart of the refinery. Some distillation towers are taller than apartment buildings. Inside, something remarkable happens. Different hydrocarbon molecules separate according to their boiling points. The lightest molecules rise toward the top. The heavier molecules remain lower down. Imagine sorting hundreds of different ingredients using nothing but heat. That's essentially what's happening inside the tower. Near the top, refinery gases are collected. Below them, gasoline-producing fractions begin separating out. Further down come jet fuel components, then diesel fuel, and near the bottom remain the heaviest materials. At this point, many people assume the refinery already has gasoline, but that's not true. In fact, the material collected from the tower still isn't good enough for modern engines. And this is where things get even more interesting. The refinery now begins changing molecules themselves. Large hydrocarbon molecules move into a unit called the catalytic cracker. The name sounds complicated, but the idea is simple. Take large molecules, break them into smaller molecules, create more gasoline. Inside these units, hydrocarbons encounter extremely hot catalysts. The large molecules literally crack apart into smaller ones. And here's the incredible part. Without catalytic cracking, the world would produce far less gasoline. This technology is one of the main reasons modern fuel production is possible at such enormous scales. As more gasoline molecules are created, the fuel moves through additional processing units. Some streams enter hydrocrackers, others enter reformers, and this is where refinery chemistry becomes incredibly sophisticated. The reforming process rearranges molecular structures to improve fuel quality. The goal is increasing octane. Why does octane matter? Because higher octane gasoline performs better inside engines and helps prevent knocking. Without proper octane levels, modern engines would not operate efficiently. At this stage, the refinery has multiple gasoline components. But there's still one problem. No single component can become finished gasoline on its own. Each stream has strengths and weaknesses. Some improve performance, some improve combustion. Now comes the stage that determines how the final gasoline will perform. Blending. Think of it like creating the perfect recipe. Computers carefully combine components from across the refinery. Every gallon must meet exact specifications. Too much of one component can affect performance. Too little of another can affect emissions. The blending process must be incredibly precise. And then come the additives. These additives may seem insignificant, but they play a major role. Some help clean fuel injectors. Some reduce engine deposits. Some improve fuel stability. Some protect metal components from corrosion. Different fuel brands often use different additive packages, and that's one reason companies advertise their fuel formulas so heavily. At this point, the gasoline is nearly complete. But before it can leave the refinery, it must survive one final challenge: quality control. Samples are sent to laboratories where technicians perform detailed testing. Octane ratings, sulfur levels, density, volatility, chemical composition. Everything is checked. Only fuel meeting strict standards moves forward. The approved gasoline is pumped into enormous storage tanks. From there, it enters one of the largest transportation systems on Earth. Pipelines carry fuel across entire states. Tanker trucks transport it to local terminals. Rail cars move it across long distances. Every day, millions of gallons move through this network. Eventually, the gasoline arrives at distribution terminals. Then, tanker trucks load the fuel and begin making deliveries to gas stations. Within days, the same crude oil that arrived looking like thick black sludge has been transformed into a highly engineered fuel capable of powering modern vehicles. And that's the part most people never see. Behind every gallon of gasoline lies an industrial process involving giant furnaces, skyscraper-sized towers, advanced chemistry, massive transportation networks, and some of the most sophisticated engineering systems ever built. So the next time you stop at a gas station and fill your tank, remember this: the fuel entering your vehicle has already completed one of the most remarkable manufacturing journeys on Earth. And that is how gasoline is made. If you enjoyed this behind-the-scenes refinery journey, make sure to like this video, share it with your friends, and subscribe to the channel for more incredible manufacturing stories from around the world. Also, don't forget to press the bell icon so you never miss our next video. Thanks for watching, and we'll see you in the next one.